Okay, this video should be fairly short. This is just simply to work through some examples so you can see what kinds of things you might be asked about parabolas in Vertex form, and so you can be really clear on both the directions and the form that your answer should take. And then the rest of class will be some kind of, I hope, group activity where you will be able to work together with some teammates to answer similar questions about them. So I'll go ahead and put the first set of directions up on the screen here. Okay, first we'll look at the directions because these are doozies of directions. There's a ton of stuff in these directions, so we're going to break it down. I'm going to give you, or we'll work through 4 different examples of this, but first you're asked to state the transformations. What that means, that's like your left, right, up, down, okay? On the last test, state the transformations, people were telling me like stuff that wasn't the transformations. So that's what we mean by state the transformations. State the vertex, that is going to be an ordered pair. State the axis of symmetry, that is going to be x equals some kind of number. The y-intercept is going to be an ordered pair with x as the 0, and then the graph is going to be an actual graph. So we've got 1, 2, 3, 4, 5 different things that we're being asked to produce. I will say that it's not necessarily the best form to go in order. So if you've got multiple things that you're looking for, you might find that it's easier to state the vertex, then state the axis of symmetry, then do the transformations. Or maybe the transformations, vertex, maybe you do want to do it in order. It's really up to you. All right, so I'm going to clear this out. I'm actually going to do a duplicate page without the ink. There we go. And let's go ahead and do the first problem. So the first one is f of x is equal to negative and then parentheses x minus 3 all squared plus 1. So we'll color code this. State the transformations. Transformations, remember, if you're asked to state the transformations, that is your flip, skinny, wide, left, right, up, down. And I can tell from this, because there's a negative out in front, that this will be flipped. I can tell from the minus 3 that it will go right 3. And I can tell from the plus 1 that it will go up 1. Now, I am actually going to jump in what I am doing, and I am going to come over here to sketch the graph. Because most of us are visual learners. Most of us do well with pictures. We like to see things ironed out in pictures. So I am going to go ahead and sketch the graph of this. I know that it goes right 3 and up 1. And so let's sketch it in we'll do it in this yellowy color. So that's my vertex. I know it's flipped over and it should be rounded. That's all at this point you need to do for the graph. Now in a future lesson, I'm going to ask for more specific information. But for now, just give me the orientation, give me the shape, and give me the location of the vertex. Now, the reason I like to sketch the graph before I come over here and answer these is because it's easier for me to state the vertex if I can see the vertex. And now I can see it, and I can see that this is at the point 3, 1. Now, I'm going to label that with a V for vertex. And there we go. Now, the next easiest thing to do is the axis of symmetry. The axis of symmetry is going to be an equation that starts with x equals, it's the equation of a vertical line, and that vertical line is going to go right through the center of the parabola, and it's going to go through the vertex. If I want to know what the x coordinate is for that line, all I need to do is look at the vertex. So I can tell the vertex is at x equals 3. So the equation for the axis of symmetry is x equals 3. Now bear with me for a moment. If I were to pick any point on that vertical line, the x coordinate of that point would be 0. Would be 3. Go me. Would be 3. I'm just used to saying 0. It's because it's my favorite number. Okay, and that's why the equation of that vertical line is x equals 3. Like, no matter where you are, x would be equal to 3. Now, the last one here actually requires you to do some calculating the y-intercept. The y-intercept is going to be where the graph crosses the y-axis. So to calculate the y-intercept, what you want to remember is that x is equal to 0. Just take a moment, think about where you are on the y-intercept. Think about all the lines when we channel Miss Braswell and we say the y-intercept is the point like 0, 3 or 0, 1 or 0, 5. It's like the x-coordinate is 0. So to calculate this, all I'm going to do is plug in x is equal to 0. And then I will be able to figure it out. So I might run out of space here. 0 minus 3 is negative 3. And just be careful. Watch what I'm doing here. Notice I have two negatives. Now, they do not cancel each other out because the because is always important here, because this negative is being squared and this one is not. I know that because this negative is in the parentheses and the parentheses are squared, but stuff outside the parentheses is not squared. So we are going to do negative 3 times negative 3, which gives us 9. This negative is still there. It hasn't gone away. So I bring it down next line and then we bring down the plus 1. I don't think that's the problem there. Okay, and so like I'll go through that again. You do the 0 minus 3, you get negative 3. These, we can't do anything with them until we do the squaring. So we do negative 3 times negative 3, which gives us positive 9, and this negative comes down. Now I have negative 9 plus 1, which is negative 8. And the y-intercept is the point 0, negative 8. Now, keep in mind, I just did a rough sketch of this. Does it seem reasonable that it could be at negative 8? Maybe, maybe not. Just bear in mind that I didn't draw that to scale. But it's certainly not way off. If I had gotten positive 8, like I could say for sure, like it's definitely not positive 8. And it's definitely not like negative 100. It's not way down off the bottom. All right, let's look at the next one. So for this next one, we'll go through it in the same order. I'm going to advocate for the same order on this because I am going to advocate for the same order. I think it's a good order to do it. So state the transformations. I know there's no negative, so it's not flipped. There's no number out in front, so it's not skinny or wide. And I'm going to steer clear of that when I ask you to graph stuff. The plus 4 inside means it does not go right. It goes left 4, and the plus 2 on the outside means it goes up 2. That's a U for up 2. Now I'm going to jump over to sketch the graph because I think it's easier for me to get the vertex and the axis of symmetry if I can see the vertex and the axis of symmetry. So let's go ahead and put a coordinate plane on here, and we are going to go left 4 and up 2. And there's my vertex. It is not flipped over. So I'm just going to draw a nice rounded bowl. And that is all you need for a graph at this point. It's just a sketch. The reason I like to do that is because I can now answer the question about the vertex. So the vertex is right here, and I can clearly see that the vertex is at negative 4, 2. Again, maybe label that with a V for vertex, so there's no question about that. The axis of symmetry, no, I don't want red, we'll do blue. Axis of symmetry is going to be x equals, and you're looking at the vertical line running right through the vertex. Keep in mind, what's the x coordinate of every single point on that line? It would be negative 4. So it's just going to be the x coordinate of the vertex. Much, much easier to do it in that order. That's my thing. You can do it your own way if you want, but it won't be the best thing ever. Remember for the y-intercept that you're looking for where x is 0. You're looking for this. Now, we can use our sketch to estimate it. I know for certain that the y-intercept should be a positive number, okay? because the parabola is clearly going upward. It's not going to end up down here somewhere. I can also say with reasonable certainty that it's probably greater than like 3 or 4 or 5. It's definitely greater than 2 because the vertex is at 2 and I know it's going up. It's probably not like 100, okay? It's not like way up here. If we get a number like that, we might want to look at it more closely. But if we get like a negative number or we get like a 0 or a 1 or a 2, we know we've done something wrong. Let's go ahead and plug in x is 0. So notice that I am changing the notation up, okay? That like I'm using f of x here, but I am switching it over to y, and you are welcome to do that anytime. 0 plus 4 is 4. 4 squared is 16, and 16 plus 2 is 18. And so the y-intercept would be the point 0, 18. Now that seems a little bit high given what my graph looks like, but it's not something that I'm sure is wrong. And we remember that the graph that we've done it's just a sketch. That's all it is. All right, let's look at the next one. Okay, this one is a simpler one, and I actually put it in here because students tend to overcomplicate these problems, and they start to make up transformations where there aren't any transformations. So I like to kind of bring it back and say, okay, not everything goes left and right and up and down and flips and is skinny and all of that. So starting with the transformations, this only does one thing, and we have a -4 on the outside. All that graph does is go down 4. That's it. It goes down 4. So don't overcomplicate stuff. Now let's go ahead and do our graph. So I put up my coordinate plane, 1, 2, 3, 4, and it's not flipped over, and so I'll just draw my parabola like so. All right, now I can actually see where the vertex is. So I can see where the vertex is. The vertex is at the point 0, -4. And for most of you, it'll be easy once you sketch the graph. The axis of symmetry. Okay, that's the line that goes right down the middle. In this case, it is the y-axis. So your axis of symmetry is the y-axis, and the equation for that would be x equals 0. Don't overthink that. That's the equation for the y-axis. And now for the y-intercept, you could go and do the same calculations that we were doing before, okay? Where x is equal to 0, but you might notice that the y-intercept is actually, like we can see it, the y-intercept is the vertex. I'll say that again, and I'll like put my pointer on it. The y-intercept, where the parabola is crossing the y-axis, and the vertex are the same point. So you can do this where you plug in the 0 for x, and you do 0 squared is 0, and 0 minus 4 is -4. So when x is 0, you get y is -4, and then you'll notice that it's the same, so you didn't really need to do that work at all. I'm not an advocate for doing extra work. Last one of these example problems. You'll notice that this is bringing it back to the parent function. So you're answering the questions on the parent function. I think we can do this pretty quickly. State the transformations. There are none. The parent function is the version that's not transformed. So if I go to sketch the graph, all I'm doing is I'm sketching the graph of the parent. Ooh. Let me do it this way. I think I'm getting okay, miraculously fixed itself instantaneously, but not really. I paused the video and fixed it. The vertex is at the point 0, 0. The axis of symmetry is going to be x is equal to 0, and the y-intercept and the vertex are the same point, and so that will also be the point 0, 0. So don't make things harder than they need to be. All right, last one of these I'm going to actually type out, and then you'll be all set to do your own work. So this one is write the equation of a parabola. I do want, oh, why do I do that? Drives me crazy. Of a parabola, okay? Not the parabola. Now there are versions of this that it would be the parabola, like there's only one, but this is a parabola, and we want our parabola to be flipped, and we want it to have its vertex at the point 3, -4. So you might feel at a loss, but before you slap down IDK or say I'm confused or I don't know what to do, I want you to remember that you actually do know some stuff. So you know what a parabola looks like. You know what it is to be flipped, and you know where the point 3, -4 is. So before you quit and before you say IDK, what I would ask you to do is sketch it. See if you can draw where this would be. So 3, -4 is going to put us right there, okay? And I want it flipped over. Now what that does, one, is going to show me that you're not quitting, that you are trying to access like what you know about parabolas and about flipping and the shape and all of that. So you're not leaving stuff blank. It's also going to help you to look at the problem a slightly different way, because now that you can see it, now you can see that this parabola goes right 3 and down 4. And you've done this before with your absolute values, where you've written the equation of an absolute value function that had certain transformations. So remember, equation has to have an equal sign. I will take off. So we're going to start it with y equals. To make, now we know it's a parabola, so that's where the squaring comes from. To make something go right 3, we subtract 3 on the inside. To make something go down 4, we subtract 4 on the outside. And to flip something over, we put a negative out front. And there you have it. Now, on your classwork, you are going to be asked to do this with several different functions, as well as what I just did. You'll be able to work together. And there is a bonus problem. I am not going to help you with the bonus problem other than to get it maybe set up, because it's a bonus. It's above, it's beyond, it's collaborative. I want to see if you can do it without my help. So while it might be frustrating for you to ask for help and I say no, and it actually makes me die a little inside because I love helping students, like the goal of it and the purpose of it being bonus is exactly to figure out what you can do without my help. So we'll break up into small groups, and you have the rest of the period to work on that assignment. If you do not finish it in class, then you have access to Teams. You can finish it for homework, but the goal is for you to finish it in class.